Facebook robot crawls along power lines to deliver fiber optic cable. Fiber optic internet is better than metal. Fiber optic cables need to be buried underground, so they can't be used everywhere. Facebook has a robot that can wrap the cable around power lines. Fiber optic cables are good for sending data. They are better than metal cables. They can send more information, they can send it faster, and they can be transmitted over long distances without any problems. Electricity is sometimes put on poles. The wind, ice, and temperature can make the electricity sag, which can cause it to break. Most companies and cities like to put your cable underground. They do this by digging trenches, laying the fiber optic cable in the trench, and then filling it back in. This is a difficult process that will cost you money and take up time. It can't be done in many places around the world. Facebook Connectivity has created the Bombix robot that can come in handy for this. This device takes its name from the Latin word meaning silkworm. It is designed to crawl along power lines and wrap a wire around them. We plan to make it so that this machine can install 1 kilometer of cable within 90 minutes. It will use sensors to automatically move around obstacles in its way, and the prototype currently has to be manually guided around them by remote control. A 1-mile-long cable is too heavy to be hanging in one place on a power line. Bombix uses a wire that has Kevlar on it. This makes it lighter weight, and the wire only goes with 24 optic fibers. Facebook says that the power lines should still be enough to give power to all of the homes and businesses they pass. Additionally, the new cable has a special outer jacket that is heat resistant and helps it not to melt or get stretched when the temperature gets very high. Although Bombix is still in development, Facebook Connectivity has already licensed the technology to high-speed internet company NetEquity Networks. The robot can be seen in action in this video. Canada's Hydro-Quebec Public Utility Company has developed a robot that can walk on power lines. This is to inspect the lines. It is called a line-crawling robot.
We're developing a robot that crawls on 10,000 to 35,000 volt lines to install miniature, super strong fiber optic cable we've developed.
Conventional cable installation on poles is very expensive relative to cable. What we chose to do is to use an existing infrastructure, the electrical conductors, to act as the carriers for the fiber optic cable. And the robot basically winds these cables around those conductors. We had a few basic parameters to start with, and we developed a set of characteristics that are very different from the standard fiber optic cables.
So the idea to utilize the electrical grid first came to me traveling around rural Africa. However rural we got, there were still medium voltage power lines everywhere we went. And this got me thinking there's got to be a way to utilize that infrastructure.
There are really two central innovations. The first is that there's an innovative fiber optic cable design that's resistant to damage. The other central innovation is the robotic system, which will allow the fiber optic cable to be transported along medium voltage distribution lines. Marrying those two technologies really enables you to run fiber in a way that couldn't be done previously.
A lot of the outdoor fiber cable used in construction come on these gigantic 6-foot spools that weigh thousands of pounds. To make this work, we needed to reduce the fiber cable diameter down to something less than 4 millimeters. We found a way to be able to carry over 1 kilometer of cable within the available clearance around the conductor and have it weigh less than 30 pounds.
We were able to take the spool of cable and deform it into a horseshoe shape. That allows the center of balance of the robot not to be shifted around the outside. So this allows us to work with conductors that are closely spaced together. And so with that, we would be able to let the robot pass over those more successfully.
The robot is able to spin that payload with this custom shape and maintain that center of mass.
We decided that the robot that installed the fiber would have to have two separate operations, one for the standard normal wrapping operation and another operation where it would lift the fiber cable up and away from the conductor to be able to pass an obstacle. Making sure that we designed a robot that could automatically navigate over this class of obstacles without any human assistance was the critical function for the robot.
We identified early on that we were going to house the payload of fiber in the middle of our robot. This allowed us to be able to lift the robot up from either side without having it cantilevered off of one end and transport it over an insulator or other obstacle.
This is a very hard problem, and I think because it's never been done before, there isn't something simple that we could rely on for guidance.
When Karthik was putting together the team, the goals were to find people and groups that were willing to look at these things with a fresh set of eyes. And I give the Facebook team a lot of credit for building a very diverse group that was willing to get outside of our comfort zones and build things that were different.
I think most people at ULC Robotics would say that this is the coolest and most difficult robot we've ever developed.
Facebook Connectivity's mission is to bring more people online to a faster internet. Our hope with this project is that we enable all different kinds of access technologies to be used. All of these things can be improved by having a more pervasive fiber optic network.